So in this video, we're gonna still talk about ellipses. So this is the second part of ellipses. So again, let's start by defining what do we mean by ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, f1 and f2, is a constant. And these two fixed points are called the foci. And the midpoint of the segment joining the foci is the center of the ellipse. So this, in our case here, we have the major axis, and then we have the minor axis, and don't forget we have the vertices. So today we're going to talk about the standard form of the equation of an ellipse centered at a center other than the origin, and we're going to name the coordinates of that center h and k. So in the first example, we have a horizontal ellipse because we have a square located under x squared greater than b squared located under y squared. Keep in mind the foci are still c units left and right from the center, and we have c squared equal a squared minus b squared. So first we're gonna graph the ellipse at the center, and now we're gonna see the translation to the new center that has coordinates 3 and 4. So notice the foci has coordinates -1, 4 and 7, 4, and the new center is 3, 4. So that's the graph of x minus 3 squared over 25 plus y minus 4 squared over 9 equal to 1. There's an easier method. First, we're going to locate the center at 3 and 4. Then we're going to take 5 units left and right and 3 units above and below the center, and that's my ellipse. Keep in mind the foci are still located at -1, 4 and 7, 4, and now we have the vertices. So the vertices are located at -2, 4 and 8, 4. Another example, and in this time we have a vertical ellipse because the quantity under x squared is less than the quantity under y squared, or in other words, we still have a squared greater than b squared, but a squared here is located under y squared. Keep in mind the foci are c units, left and right from the center, and c squared, in our case here, we have it as 5, therefore c is equal 5. Therefore, the foci has coordinates as such. First, we're going to graph the ellipse at the center. And then we're going to translate it to the new center of coordinates 1 and -2. So now we're going to translate everything to a new center of coordinates 1 and -2. So these are the coordinates of the foci also. And then the graph of my new ellipse. Now we have an easier method. First, we're going to locate the center at 1 and -2. Then we're going to take 2 units left and right, then 3 units above and below the center, and that's my ellipse. Don't forget the coordinates of the foci, and now we have the coordinates of the vertices. Keep in mind, because it's vertical ellipse, the center and the vertices are parallel to the y-axis. We have another example, and this time we have a horizontal ellipse. So we calculated the coordinates of the foci. First, we're going to graph it at the center, and then we're going to translate it to the new center of coordinates -3 and 2. So the new center has coordinates -3 and 2. Again, we have an easier method. We can locate the center first. We have it at -3, 2. Then we're going to take 4 units left and right, then 1 unit up and down from the center, and that's my ellipse. These are the coordinates of the foci, and now we're going to see the vertices. Now here we have equation of an ellipse written in standard form, so we need to determine the center and the length of the major and minor axis. So we're going to use the method of completing the squares. So first we're going to group the x variable. Now we're going to factor out the 5. So we're using the method of completing the square. After using that method, so now we can pull what's the coordinates of the center and what's the length of the major axis and the length of the minor axis. We have another example. We need to determine the center as well as the length of the major and minor axis. So we're going to use the method of completing the square. Therefore, the center is -5, 2, and the length of the major axis is 8, and the length of minor axis is 4.